Hi everyone, today we're going to learn how to express one quantity as a percent of another quantity. So to start off, we're going to need to review some important vocabulary words. Quantity is the actual amount or number of things that we're talking about. And percent is a percentage out of specifically 100. So quantity is just how many, and you can actually count. And percent is when we're talking about out of the whole of 100. So very specific. So for example, I can eat 4 slices of pizza, and those 4 slices are my quantity because I literally have 4 slices. I can count them on my fingers. But the percent would be 50% because we're taking it out of the entire pizza, which would be that 100%. So the 100%, the entire thing, is 8. I only ate 4 out of the 8. So that is actually equal to 50%. So the 4 is the quantity, the 50 is the percent. How do we find that 50%? You can take 4 and divide it by 8 to get 0.5 or a half. And to turn it into a percent, you're going to need to multiply by 100 to get to that 50%. So you have your part out of your whole. And remember, after you divide it, you have to multiply by 100 because the percent is out of 100. So that's just an example. We're going to go through other examples as well from the book. But be sure to write down these important vocabulary words. And we're going to go over some more examples where we have to figure out the percent, where we're going to divide the part and the whole and then multiply by 100. All right, here is our first example from the book, example 3. There are 96 students in a choir and 54 of them are girls. Find the percentage of A, girls in the choir, and B, boys in the choir. You can go ahead and pause the video and try this on your own first. Okay, so they need to find the percentage of A, the girls in the choir, and B, the boys in the choir. So like we did before in our pizza example, we're going to need to figure out the part, divide that by the whole, and then multiply it by 100 to figure out the percent. So if we want to figure out the girls in the choir, the girls are a part of the choir, the entire choir. So we need to take the amount of girls and divide by the entire choir before multiplying by 100. There are 54 girls. We're going to divide that by the entire choir, which is 96. Take that answer and then multiply by 100. So let me go ahead and do that. Okay, so 54 divided by 96 is equal to 0.5625. We still have to multiply by 100. And so we end up with 56.25. So that's our answer. 56.25%, or 56.25%. That would be our answer for part A. There is about 56% of girls in the choir. Okay, and then the next part is figuring out how many boys are in the choir. So you could do the same thing, take the amount of boys, divide it by the choir, the entire choir amount, and then times 100. There's going to be 96 minus 54, that's 42 boys, divided by 96 times 100, right? Because they're going to be whoever's left over, we would assume. So then 42 divided by 96 times 100. So you would get 43.75%, or 43 3/4%. Or the quicker option would be to take 100 and subtract the answer from part A, 56.25, and you would get the same answer. Shortcut way. But I'm just showing you that it would be the same exact formula, except you would take the number of boys, so changing the part amount, divided by the same whole amount, the entire choir, and times 100. So always part divided by whole times 100. So if you don't have that equation or that formula written in your notes yet, if I were you, I would do that. So this formula right here helps you find the percent when you have part and whole. When you have the part and whole. Okay, so again, put that into your notebook if you don't have that yet. Okay, on to another example. Example 4 says the following table shows Julia's results in 3 tests. Test number 1, the maximum possible score is 20 points. Julia scored 17 points. 17 out of 20. And for the second test, there were 45 points. Julia scored 36 points out of the 45 possible points. Third test, 30 possible points. She scored 25 points out of 30. So this probably looks familiar. It kind of looks like the score I would give you on a test. And then right next to that, I would write the percentage and circle that for you, right? So we want to know which test result is the best, because these are out of different wholes, right? Different possible total scores. So just because she scored 36 points on the second test doesn't mean she did the best, because it was actually out of 45 points, right? And even though she scored only 17 points, well, the total possible score was out of 20, so she was just 3 points away from 100%. So we really need to figure out the percent for each of these tests. Notice how the question doesn't ask for the percent, but that's really what we need to find. We need to find the percentages and then find the highest percent. Okay, so go ahead and pause your video and figure that out on your own first. Okay, so let's go ahead and do that. Test 1, she got 17. So remember, we're taking the part divided by the whole, and then take that answer and multiply by 100. So she got a 17 out of the 20 possible points, 17 out of 20. So we need to take that part, divide it by the whole, and multiply by 100 to get that percent. For the second test, same thing, take the part. She only got 36 points out of 45 total points, divide by the whole, multiply that answer by 100. Number 3, or third test, same thing, the part, divide by the whole, times 100. So that will give us each of the percentages. Let's go ahead and do that. The first one, 17 divided by 20 equals that, times 100. So the answer is 85%. Not bad, that's a solid B. Next one is 36 divided by 45. Let me clear that first. 36 divided by 45, and then times 100. So that's 80%. And then for the third test, 25 divided by 30 take that answer, whoa, times 100. So the answer is like an 83.3. 83.3%. Okay, so again, just because she scored the most points on test 2 doesn't mean she actually got the highest score, right? Because it was out of a bigger hole. So she only scored 80% there. That was actually her worst test. Her best test was test 1. Test number 1 was the best. Test number 1. She got an 85%. Overall, she got a B average, but that was her highest B. Okay, let's move on to our last example. Example 5. The t-shirts in a store are of sizes L, M, and S, or large, medium, and small. A total of 180 t-shirts are sold in a day. So total tells you that's going to be your whole. If 20% of the t-shirts sold are of size large and 45% are of size medium, how many t-shirts of each size are sold? Go ahead and pause the video and try it on your own first. Okay, so a couple things you can do here. You could use that formula, the part divided by whole times 100 to equal your percent, and kind of work backwards because they gave you the percent, right? So you can kind of do inverse operations to go backwards. For example, if the large sizes are 20%, then you kind of can work backwards. We know what the whole is, 180, so we don't know what the starting amount is. So you can kind of work backwards and say, okay, so then X would equal to everything going backwards, 20. We multiply by 100 to get to 20, so now we're going to divide by 100, and then we divide it by 180 to get to that answer, so we're going to multiply by 180. So you can do that. You can kind of work backwards. So we would do, okay, 20, let's see, divided by 100 times 180 to get 36. So 36 larges. So let's just check it. If there were 36 larges, 36 divided by the whole, which was 180, times 100 should have gotten us back to the 20%. Yeah, this 20% right here. So you could do that, work backwards, and then let's see, the mediums were 45%. So then same thing. Let's see, the mediums would be the 45, divide by 100, because normally you would times 100. You're doing everything backwards. And then times 180, because normally you would divide by 180 the whole, the total. And then you could do that to get to your answer. So 45, clear that, 45 divided by 100, inverse operations, and then times 180 the whole instead of dividing, and you get 81, what is that, mediums. Okay, and then if they want to know smalls, well then you would just subtract that from your total. If my total was 180 shirts, then the smalls would equal to 180 minus my 36, my larges, minus my 81, my mediums. So 180 minus 36 minus 81. So my smalls would be 63 smalls. Okay? Yeah, so using a concept we've learned before, inverse operations. So that's where they give you the percent, and you got to work backwards to figure out what was the number that we started with. So then you're going to do everything backwards. Instead of multiplying by 100, you're going to divide by 100. Instead of dividing by 180, you're going to multiply by 180, kind of retracing your steps. The other way you can solve this is using what we call it a double number line. And that might actually, if you didn't like that method we did before, that might actually work with your brain better because it's a more visual way of looking at it. And it's a method that I've come to appreciate more and more. So basically on your double number line, you have one side, top or bottom, that's the percents. So 0 to 100%. And the bottom one, which is your quantities, something that we talked about before, right? So the top is your percents and the bottom is your quantities. So let me write quantity. So the actual number of t-shirts, and then the top is your percent. Okay? 0% of the t-shirts would be 0 t-shirts. 100% of the t-shirts would be the entire thing, which is the total of 180 t-shirts. So these percents have to line up with the quantity. 0 t-shirts means 0%. 180 t-shirts means 100%, the total amount of t-shirts that are sold in a day. So then you're going to do the same thing with your t-shirts, the percentages they gave you. So 20% of the t-shirts are larges. So 20% would be right over here. We don't know how many are larges, but we know 20% are large. So then you would use your double number line to, you're going to divide up your double number line. So for example, I know that 20%, there are, let's see, if I jump 20% each time to 4, this would be 40%, 6, 60%, and then 80%, right? To 20%, 40%, 60%, 80%, 100%. So we're basically adding up 20% each time. Well, that would be 1, 2, 3, 4, 5 different sections that make up 100%, right? Because 20% times 5 will get you that total of 100%. So basically they're divided into 5 different parts. Well, then I can take that and do the same thing with 180. 180, divided by 5. Let's see what that is in our calculator. 180 divided by 5 is 36. So that means that each of these 5 sections is equal to 36 extra t-shirts. So 20% would be 36 t-shirts. 40% would be 36 plus another 36, which is 72 t-shirts. 60% would be 72 plus another 36, which would be 108 t-shirts. 108 plus 36 would get me to 80% of the t-shirts. I'm going to use a calculator for that. I can't do that in my brain right now. Talking and doing math. 144. And then 144 plus another 36 to prove to you in the calculator. 144 plus 36 would get us to the 180. So basically you're like, well, 20%, there are 5 20% that make up 100%. So then I just need to take 180 and divide that into 5 parts as well, and I'll get that answer. 36 t-shirts are 20%. And then you could do the same thing to figure out the mediums. 45% are mediums. So then you can figure out, okay, well, if 72 is 40% and 108 is 60%, I can figure out the middle to get 50%. Let me actually use a different color so that you can see what I'm doing a little easier. So this one would be halfway. So that would be 50%. So then we would figure out what's halfway between 72 and 108. I don't know, 108 minus 72 is 36. So then take that divided by 2, that would be 18 plus 72. So it looks like 90 is between 72 and 108. So 50% would be 90 t-shirts. Oops. 90. So then if we want to figure out 45%, I'll use a different color. 45% would be between 72 and 90. So what's between 72 and 90? Well, 90 minus 72 is 18. Divide that in half, so it's 9. 9 plus the 72 would mean that's 81. 81, what was that? Mediums. A lot more work here, to be honest, right? But you basically can figure out any percentage using your number line by basically dividing it up into different sections. So again, that's just a different method. And honestly, when problems get very complicated and I can't quite remember my formulas, I like to use a double number line because it's easy to kind of build it and break it down and multiply and all that from scratch. And it makes sense. I can check my work and check how reasonable my answer is and see if it makes sense. Okay, so that's just a second method for you to put into your toolbox in case you forget the first method.